Have you ever looked up at the night sky and felt that strange pull, the one that makes you wonder about the vast mysteries hidden in those twinkling dots of light? For thousands of years, humans have tried to capture the cosmos not just through calculations and telescopes, but through something just as powerful: art. From ancient star maps etched into cave walls to breathtaking digital galaxies crafted by today's artists, creativity has always been our silent partner in decoding the universe. What if I told you that some of the most groundbreaking discoveries in astronomy were sparked not just by data, but by the stroke of a brush or the curve of a sculpture? This is the magic that happens when art and science collide, where imagination gives shape to the invisible and beauty leads us to truth. Today, we're diving into this extraordinary partnership, from the earliest stargazers who painted their visions onto stone, to modern teams of scientists and artists working side by side to visualize black holes and distant galaxies. By the end of this journey, you'll see the night sky and the tools we use to understand it in a whole new light. So let's begin where curiosity meets wonder, where art doesn't just illustrate the cosmos but helps unlock its deepest secrets. Those ancient stargazers didn't just observe the heavens, they painted them into existence. Take the Egyptians, for example, who didn't merely chart the stars but wove them into the very fabric of their temples and tombs. The ceilings of burial chambers became cosmic canvases, adorned with constellations that guided pharaohs to the afterlife. Meanwhile, half a world away, the Mayans carved precise astronomical cycles into their pyramids, turning stone into a celestial calendar that predicted eclipses with astonishing accuracy. These weren't just decorations, they were scientific records etched in beauty. Fast forward to the Renaissance, when visionaries like Leonardo da Vinci blurred the line between artist and scientist. His sketches of the moon, drawn centuries before telescopes, captured the play of light and shadow with such precision that they hinted at the lunar surface's texture. And then there's Galileo, who didn't just peer through his telescope, he translated what he saw into delicate ink-wash drawings, turning Jupiter's moons into art that could convince a skeptical world. Even in the darkness of prehistoric caves, humanity left whispers of the cosmos. A painting in what's now Turkey might depict the supernova of 10,066, a star's death frozen in ochre and charcoal. And medieval monks, hunched over parchment, painstakingly illustrated star maps with gold leaf, blending faith and astronomy into illuminated manuscripts. What's extraordinary is how these ancient creators didn't separate art from science. A Mayan priest calculating Venus's path, a monk gilding Orion's belt. They understood that to study the heavens, you had to feel them too. That legacy lives on today when astronomers partner with digital artists to sculpt black holes from equations, or when a satellite's raw data becomes a swirling, colorful nebula on your screen. The truth is, every time we visualize the cosmos, we're standing on the shoulders of those who first painted the stars. Think about the last time you saw a stunning image from the Hubble Space Telescope, those swirling galaxies rendered in sapphire and gold, or the pillars of creation glowing like interstellar sculptures. What you might not realize is that those iconic visuals aren't snapshots in the traditional sense. They're collaborations where raw data meets an artist's intuition. Modern astronomy deals with wavelengths invisible to the human eye: X-rays, radio waves, infrared light, and it's artists who translate those signals into colors we can recognize. Take the Chandra X-ray Observatory, for instance. Its data arrives as streams of numbers, but through partnerships with digital illustrators, those numbers become vivid cosmic landscapes. A jet of particles from a black hole isn't just a graph. It's a fiery ribbon cutting through space, its hues chosen deliberately to show energy levels or temperature gradients. Even the now famous first image of a black hole, released in 2019, required an international team of scientists and visualization experts to transform radio telescope data into that glowing, donut-shaped icon. But this isn't just about making science pretty. When researchers at the European Southern Observatory studied distant exoplanets, they worked with artists to render hypothetical skies from those worlds not as fantasy, but as informed estimates based on atmospheric chemistry and light scattering. These visuals do something equations alone can't. They let us step into the unknown. A child staring at a 3D simulation of a supernova remnant isn't just memorizing facts, they're feeling the scale, the violence, the beauty of the universe. That emotional resonance matters. It's why museums embed planetarium shows with original animations, and why textbooks increasingly commission space artists alongside photographers. The result, a generation that sees science not as cold calculations, but as a story waiting to be told, one where artistry doesn't just accompany discovery, but actively shapes how we understand it. Vincent van Gogh's swirling, starry night does more than hang in a museum. It pulls viewers into the emotional turbulence of the cosmos, proving art's power to make the universe feel personal. Long before space telescopes, painters like Chesley Bonestell were crafting hyperrealistic visions of Saturn's rings or lunar craters, images so convincing they shaped how an entire generation imagined space travel. These works didn't just reflect scientific knowledge, they ignited it. When Bonestell's illustrations appeared in magazines like Collier's in the 1950s, they weren't mere fantasies, they were blueprints, inspiring engineers to turn those artistic visions into the rockets and spacecraft of the space age. Today, that legacy evolves through immersive experiences like VR installations where users float through nebulae, or light projections that transform city buildings into rotating galaxies. Exhibitions like NASA, A Human Adventure, take this further, placing actual spacecraft alongside interpretive art. Say, a sculpture of the Milky Way woven from aerospace-grade wiring, reminding us that exploration has always been both technical and deeply human. Even music joins this symphony. Composers create soundscapes from radio emissions of distant pulsars, turning cosmic vibrations into melodies. What makes these connections so powerful is their ability to bypass jargon and equations, speaking directly to our sense of wonder. A child walking through an interactive exhibit on black holes isn't memorizing Einstein's formulas. They're feeling the gravitational pull, their outstretched hand distorting a projected starfield. Museums leverage this by pairing ancient astrolabes with digital animations, showing how our tools and our dreams have evolved. And when artists collaborate with institutions like the European Space Agency, the results transcend education. A mural based on exoplanet data isn't just a teaching aid, it's a bridge transforming public support for missions into something visceral. After all, people protect what they love, and they love what moves them. That's why space agencies now employ artists in residence, recognizing that the next giant leap in exploration might begin not with an equation but with a brushstroke. Today's most groundbreaking cosmic discoveries often begin with an unexpected partnership, a scientist and an artist huddled over the same dataset, seeing it through different lenses. The European Space Agency's Space in Images initiative is a perfect example, where raw telescope data becomes a collaborative canvas. Photographers and digital artists work alongside astronomers, transforming infrared readings into vibrant portraits of distant nebulae or radio waves into swirling galactic textures. These images do more than educate, they evoke. A carefully colorized rendering of a star's death can make the public grasp the drama of a supernova in ways a graph never could. Meanwhile, the SETI Institute's artist residencies take this even further, inviting painters, musicians, and even poets to interpret the search for extraterrestrial intelligence. One composer turned radio telescope signals from distant pulsars into an orchestral piece, translating the rhythm of the cosmos into something audiences could feel in their bones. On the flip side, astronomers are borrowing tricks from artists to see the universe anew. Machine learning algorithms trained on artistic principles of pattern recognition now help identify subtle irregularities in exoplanet atmospheres, clues to potential life. A sculptor's understanding of light and shadow might inspire a new way to model dark matter's invisible grip on galaxies. These collaborations thrive in artists in labs programs worldwide, where creatives embed in research facilities like CERN or NASA's Jet Propulsion Laboratory. Imagine a ceramicist crafting pieces based on the fractal geometry of asteroid surfaces, or a VR designer building immersive simulations of quantum fluctuations. The boundaries blur in the best way possible. When a painter interprets Mars rover data as an abstract landscape, or a dancer choreographs movements based on gravitational wave patterns, they're not just decorating science, they're expanding how we perceive it. This synergy reveals a profound truth. Creativity isn't the opposite of logic. It's the secret ingredient that helps logic leap forward. After all, some of history's greatest scientific breakthroughs came from moments of intuitive, almost artistic insight. Newton's apple, Archimedes' bath, Kekule's dreaming vision of a snake biting its tail. Today's artist astronomer teams are following that same tradition, proving that the next cosmic revelation might come as easily from a brushstroke as from a telescope. Why do images of nebulae, those vast clouds of cosmic dust and gas, feel almost hypnotically beautiful to us? It turns out there's a fascinating scientific explanation behind that pull. Researchers studying human perception have found that our brains are wired to respond to certain visual patterns, and nature has embedded those very patterns into the fabric of the universe. Take fractals, for example, the infinitely repeating geometric shapes found in snowflakes, ferns, and even the branching of neurons. These same fractal structures appear in the tendrils of distant nebulae, the spiral arms of galaxies, and the turbulent flows of solar flares. When we gaze at Hubble's images of the Carina Nebula with its intricate branching plumes of gas, our brains recognize that familiar rhythm, triggering a sense of awe. But it's not just patterns, it's also symmetry. Studies show humans instinctively prefer symmetrical shapes, likely because symmetry signals stability and order in nature. From the perfect disk of a protoplanetary ring to the mirrored jets exploding from a young star, the cosmos serves up symmetry on a grand scale. Then there's color. While many iconic space images apply false color to highlight different wavelengths or chemical elements, those vibrant hues are carefully chosen. Deep blues evoke tranquility, fiery reds signal energy, and ethereal purples suggest mystery, palettes that tap into deep-seated emotional responses. Neuroscientists have found that such visuals don't just catch our attention, they enhance memory retention. When a complex concept like stellar nucleosynthesis is paired with an arresting image of a glittering star cluster, our brains are more likely to latch onto the science behind it. Museums and planetariums leverage this instinctively, using immersive visuals to make abstract concepts tangible. Think of it this way: when a child sees a supernova rendered in gold and crimson, they're not just learning about an exploding star, they're feeling its drama. This synergy between aesthetics and science isn't accidental. Teams at institutions like NASA Chandra X-ray Center collaborate with designers to ensure their visuals aren't just accurate but emotionally compelling. The result, a bridge between data and wonder, where the beauty of the cosmos isn't just a bonus, it's a tool that helps us grasp the universe's grandest mysteries on a gut level. After all, the same instinct that makes us pause at a sunset might be the very thing that propels us to explore beyond it. When the TRAPPIST-1 system revealed its 7 Earth-sized worlds huddled around a dim red sun, scientists weren't the only ones captivated. Artists stepped in to give these distant orbs faces we could recognize. Digital painters and 3D modelers took sparse data points, estimated masses, orbital distances, hints of possible atmospheres, and spun them into lush, speculative landscapes. One rendering showed a planet with twin sunsets, its crimson sky streaked with icy clouds. Another depicted rocky shores lapped by alien tides under a permanent twilight. But here's what's extraordinary. These weren't just flights of fancy. Each artistic choice carried scientific weight. The way light filtered through an imagined haze hinted at atmospheric density. The presence of oceans in some scenarios forced researchers to reconsider tidal locking's effects on liquid water. Suddenly, art became a sandbox for testing theories. Now tools like Unreal Engine take this further, building real-time exoplanet simulations where scientists can virtually walk through terrains adjusted on the fly, adding a methane lake here, tweaking gravity there, to see how changes might affect habitability. It's a feedback loop. An artist's textured canyon might prompt an astronomer to model erosion patterns in low gravity, while a scientist's radiation data could lead the artist to redesign vegetation with UV shielding pigments. Even NASA, a jet propulsion laboratory, employs visual storytellers to craft plausible exoplanet scenarios, not for publicity, but because the act of visualization sparks new questions. What if that purple forest bends light differently due to exotic photosynthesis? Could those hexagonal cloud patterns suggest unknown atmospheric dynamics? By giving form to the unknown, these collaborations turn abstraction into something researchers and the public can grapple with emotionally and intellectually. The next time you see a painting of an alien sunset, remember, it might not just be inspiring future astronauts, it could be quietly shaping the equations of astrobiologists. Imagine listening to the gentle hum of a distant star or the deep, resonant echo of a black hole's gravitational pull. Sound, it turns out, is one of the universe's most overlooked languages, and projects like NAS, a black hole sonification, are finally giving it a voice. By translating electromagnetic waves into audible frequencies, scientists and musicians have created eerie, beautiful soundscapes that let us literally hear cosmic phenomena. The haunting tones of the Perseus galaxy cluster, for instance, ripple through space as deep, undulating notes, each vibration representing pressure waves traveling through hot gas, a celestial melody hidden in data for decades. But this isn't just artistic experimentation. Turning telescope data into sound has unlocked surprising scientific insights. Researchers at MIT found that converting radio emissions into audio helped them identify subtle patterns in pulsar signals, patterns that might have gone unnoticed in visual graphs. Meanwhile, at the University of Toronto, astronomers used sonification to detect rhythmic oscillations in distant quasars, like cosmic heartbeats buried in noise. On the artistic side, composers are weaving these cosmic sounds into symphonies. The Kronos Quartet Sun Rings, for example, incorporates actual solar wind data recorded by NASA Voyager probes, transforming charged particle fluctuations into haunting string arrangements. Even planetary orbits get a musical treatment. Jupiter's moons, with their precise gravitational dances, have been assigned musical intervals, creating harmonies that mirror their celestial mechanics. This fusion of science and sound does more than entertain. It democratizes discovery. For visually impaired audiences, sonification offers a tangible way to experience the cosmos. And for researchers, listening to data can reveal anomalies like an off-key note in a stellar composition that hint at undiscovered phenomena. From the chime of a meteorite's impact to the basso profundo of a collapsing star, the universe is singing. All we had to do was learn how to listen. When an artist paints a cratered exoplanet bathed in an emerald glow, or sculpts towering crystal forests on a world light years away, they aren't just creating, they're influencing how we imagine life beyond Earth. But here's the dilemma. What happens when those breathtaking visions stray too far from plausible science? A crimson sky might be visually striking, but if it's based more on artistic flair than atmospheric chemistry, it could subtly shape public expectations, fueling misconceptions. The debate isn't about stifling creativity, it's about anchoring it in reality. Take the case of early Mars illustrations, which often depicted lush canals and alien civilizations long after scientists knew the planet was a barren desert. Those romanticized images lingered in popular culture for decades, making it harder to reset public understanding when clearer data emerged. Today, organizations like the International Astronomical Union address this tension with guidelines that encourage artists to distinguish between fact and fantasy. A rendering of a potentially habitable exoplanet might include footnotes explaining which features are confirmed, say, a rocky surface versus speculative like purple vegetation. Some studios even employ science consultants to vet designs, ensuring that a planet's proposed auroras or cloud formations align with physics, even if the details are imagined. The goal isn't to eliminate wonder, it's to channel it thoughtfully. After all, speculative art has driven real-world science before. The iconic Mars as a Second Earth paintings of the 1960s, though inaccurate, inspired generations of researchers. The key is transparency. When a digital artist collaborates with astrobiologists to depict microbial life in Europa's subsurface ocean, the result isn't just a pretty picture. It's a hypothesis rendered visible, inviting scrutiny and curiosity rather than mistaking speculation for truth. By embracing both accuracy and imagination, space art becomes more than decoration. It becomes a conversation, one where the brushstrokes of creativity help us ask better questions about the universe we're only beginning to explore. The delicate interplay of light and shadow that Renaissance masters like Caravaggio perfected isn't just a feast for the eyes, it's a tool that revolutionized how we map the moon. When early astronomers turned their telescopes to the lunar surface, they faced a puzzle: how to distinguish craters from mountains in those grainy, monochrome images. The solution came from an unexpected place: art. By applying chiaroscuro techniques, the same ones painters used to create depth on canvas, researchers learned to read the subtle gradations of sunlight hitting the moon's jagged terrain. A faint shadow here, a bright highlight there, these became the clues that revealed the moon's topography with startling precision. Fast forward to today, and the legacy of that artistic insight lives on in surprising ways. Take the algorithms now analyzing distant galaxies. By borrowing the loose, dynamic brushstrokes of Impressionist painters, astronomers can track the movement of stars within spiraling galaxies, capturing their fluid motion in ways rigid mathematical models might miss. Even artificial intelligence has joined this creative exchange. Tools like Google's Deep Dream, initially designed to generate hallucinogenic art by enhancing patterns in images, have been repurposed to sharpen blurry telescopic data. Those surreal, dreamlike filters, they're now teasing out faint galactic structures hidden in noise, turning cosmic static into usable information. What's remarkable is how these artistic techniques solve problems pure science couldn't crack alone. A Van Gogh-style swirl algorithm might reveal the gravitational dance of colliding galaxies, while a pointillist-inspired pixel analysis could uncover clusters of dark matter. This isn't just borrowing, it's a full-blown collaboration where the artist's toolkit becomes as vital as the mathematician's equation. Whether it's using Japanese sumi e-ink techniques to simulate black hole accretion disks or repurposing abstract expressionist color fields to visualize quantum foam, the boundaries between disciplines keep blurring. And every time they do, we gain a fresh lens to see the universe. not just as data points, but as a dynamic, ever-evolving masterpiece. The sleek curves of a SpaceX rocket aren't just engineering marvels, they're a deliberate aesthetic choice, echoing the same futuristic optimism that Stanley Kubrick etched into our collective imagination with 2001: A Space Odyssey. That film's minimalist white interiors and spinning space stations didn't just predict technology, they defined how generations would envision the future of exploration. But space art's cultural power runs deeper than inspiration. It rewrites the script of who gets to belong among the stars. Take Afrofuturism, where visionaries like Octavia Butler and artist Jean Mitchell Basquiat reimagined cosmic voyages through diasporic lenses, painting galaxies thick with the rhythms of jazz and the resilience of ancestral memory. Their work confronts a history where space narratives often centered one kind of hero, offering instead constellations filled with diverse faces and untold stories. Meanwhile, on city streets from Berlin to Bogota, murals of astronauts helmeted in traditional motifs, samurai armor, Maasai beadwork turned public walls into celebrations of communal identity. These images do more than decorate. They declare that space isn't just for the privileged few, but a shared frontier. Yet for all its idealism, space art also holds up a mirror to darker truths. Protest artists subvert glossy rocket ads by painting satellites as surveillance tools or rendering Mars colonies as stark commentaries on earthly inequality. Even children's toys become canvases for critique, like DIY models of recycled spacecraft, challenging the waste of billionaire space races. This push and pull between aspiration and accountability reveals art's unique role in shaping not just how we see the cosmos, but how we act toward it. When a muralist reinterprets the pillars of creation with climate crisis symbolism, or a sculptor welds discarded satellite parts into a peace monument, they're weaving ethics into the fabric of exploration. Because every stroke of the brush, every welded joint asks the same question. As we reach for the stars, who do we take with us and what kind of universe are we trying to build? Virtual reality is transforming how we experience the cosmos, turning what was once confined to planetarium domes or textbook diagrams into something you can reach out and touch or float through. Take Titans of Space, a VR tour that shrinks you down to the size of a grapefruit beside Jupiter's swirling storms, or lets you drift through Saturn's rings close enough to see the icy fractures in each fragment. It's not just scale that astonishes, it's the artistry. Developers collaborate with astrophysicists to ensure every crater on Mercury and every hue in the Orion Nebula adheres to scientific data, while also crafting lighting and textures that feel cinematic. But VR's magic lies in its ability to resurrect lost cosmic perspectives. Imagine strapping on a headset and standing in the center of Stonehenge as it was 4,000 years ago, watching the summer solstice sun align perfectly between the ancient stones, an experience painstakingly reconstructed using laser scans and archaeoastronomy research. Or walking the decks of a hypothetical generation ship, its rotating habitat ring casting shadows across hydroponic farms, a vision borrowed from both engineers and concept artists. What makes these virtual journeys revolutionary isn't just their spectacle, it's their accessibility. A student in a classroom without a telescope can now witness a supernova's shockwaves ripple past them in 3 dimensions. A grandfather with fading eyesight can hold the moon in his palms, tracing its Maria with his fingertips. Even abstract concepts like space-time curvature become visceral when you're virtually plummeting toward a black hole's event horizon, watching stars distort into streaks of light around you. Museums are seizing this potential, replacing static dioramas with interactive exhibits where visitors can rearrange galaxy clusters with a wave of their hand, or step inside a life-size model of the James Webb Space Telescope as it unfurls in zero gravity. The line between educator and artist blurs here because to build these worlds, you need equal parts precision and poetry. A VR programmer might spend weeks perfecting the physics of a neutron star's gravity, only to team up with a lighting designer to make its lethal pull feel eerily beautiful. This isn't escapism, it's empathy on a cosmic scale. When you virtually floated through the pillars of creation or watched Earth rise over the lunar horizon, experiences once reserved for astronauts, you don't just learn about space. You feel your place within it. Picture this, a Petri dish glowing with delicate bacterial colonies arranged not randomly, but in precise formations mimicking the Pleiades star cluster. This is bioart where living organisms become the medium, and the cosmos serves as the muse. Artists like Suzanne Anker have cultivated microbial galaxies in agar gels, their radiant patterns mirroring Hubble's deep field images. But these creations aren't just aesthetic experiments. By manipulating growth conditions, altering temperatures or nutrient gradients, they demonstrate how life adapts to extremes, offering tangible parallels to astrobiologists hunting for organisms in Martian ice or Europa's subsurface oceans. Meanwhile, other artists venture into genetic storytelling. Imagine algae edited with CRISPR to thrive in simulated Titan conditions, their cells restructured to metabolize liquid methane instead of water. Or fungi genetically tweaked to fluoresce in patterns matching radio telescope signals from exoplanets, a living, pulsing response to distant cosmic whispers. These speculative organisms, though Earth-bound, force scientists to confront provocative questions. Could silicon-based life pulse slowly under a red sun's dim light? Might ammonia replace water in alien veins? By materializing these possibilities, bioartists don't just imagine alternate biologies, they create working hypotheses dressed in agar and DNA. Institutions like the University of Westminster's Alien Lab take this further, hosting collaborations where microbiologists and sculptors co-design xenobots, tiny, programmable life forms that could inform robotic probes for ocean worlds. Even NASA has taken note, funding projects like Living Light, where bioluminescent bacteria map hypothetical exoplanet atmospheres across gallery walls. The result, a dialogue where Petri dishes become bridges between disciplines, proving that the next breakthrough in astrobiology might emerge not from a telescope's eyepiece, but from an artist's incubator humming quietly in the corner of a studio. There's a cruel irony in how humanity's brightest achievements, our glowing cities, have quietly erased the very stars that once guided us. Across the globe, artificial light drowns out the night sky at a rate of about 2% each year, meaning a child born today might see only half the stars their grandparents did by the time they turn 30. But artists and astronomers aren't letting this cosmic fade to black go unchallenged. Take the Lost Constellations project, where illustrators collaborate with indigenous elders to recreate star lore now invisible to urban communities. One haunting series paints the Maori constellation Tiakaroa, the Milky Way's celestial fish, as a ghostly outline against orange-tinted skies, its stars erased by the same city, lights that illuminate the gallery walls displaying it. These works aren't just memorials, they're calls to action. Projects like Globe at Night fuse art with activism, inviting people worldwide to sketch visible constellations from their backyards. The result, a stunning and sobering global mosaic where vibrant starscapes from rural Chile fade into blank, light-polluted voids over Tokyo or New York. But here's where creativity sparks change. When the Spanish artist collective Luz Interruptus staged an installation with hundreds of glowing orbs in Madrid's Plaza Mayor, each bulb represented a star no longer visible overhead. The visceral impact moved city officials to revise lighting ordinances, proving data alone rarely shifts policy, but art that makes the invisible visible can. Meanwhile, photographers like Harun Mehmedinovic's Skyglow project capture time lapses of vanishing Milky Way vistas, their images smuggled into urban ad spaces normally reserved for neon commercials. Even children's books now feature glow-in-the-dark inks that only reveal constellations when read under night vision, friendly red lights quietly teaching the next generation what's at stake. The fight for dark skies has found its most potent weapon, not petitions or pie charts, but the emotional resonance of a brushstroke tracing stars we've forgotten how to see. As one Navajo elder told a group of light pollution researchers while pointing to a single visible star above Phoenix, "That's not just a dot up there. That's my grandfather's campfire." Art, it turns out, doesn't just document loss, it reignites our longing to look up. Quantum physics often feels like trying to describe fireworks using only sound. You know something extraordinary is happening, but the language falls short. That's where art steps in, turning the subatomic world's chaos into something our minds can grasp. Take quantum entanglement, for instance. The math behind it, particles instantaneously influencing each other across light years, is dizzying. But when a kinetic sculptor strings together hundreds of mirrored fragments that move in perfect sync no matter how far apart they're suspended, suddenly the idea clicks. Those shimmering, interconnected pieces become a visual metaphor, transforming an abstract theory into an emotional experience. Then there's superposition, the mind-bending notion that particles exist in multiple states until observed. The exhibition Quantum Shadows tackles this with holograms that shift form as viewers walk around them. One moment, you're staring at an electron as a wave rippling across space. The next, it snaps into a pinpoint particle, all depending on your perspective. It's more than a clever trick, it's a doorway into quantum weirdness. Scientists collaborating on these projects report something fascinating. Even seasoned physicists gain fresh insights by seeing their equations rendered in light and motion. But the real magic happens when these artistic interpretations spark public dialogue. A textile artist weaving a tapestry of parallel universes, each thread a branching timeline, doesn't just illustrate the multiverse. She invites viewers to wrestle with its implications. Could choices in one reality echo across others? Might we, like those threads, be part of some grander weave? Suddenly, coffee shop conversations turn to quantum possibilities, all because art made the intangible tactile. This synergy even feeds back into research. When a choreographer translates particle collision data into dance, physicists notice rhythms in the data they'd previously overlooked. A painter's abstract interpretation of dark matter's distribution might inspire a new algorithm for mapping its invisible grip. What emerges is a beautiful paradox. To explore the universe's smallest scales, we need humanity's oldest tools, creativity and storytelling. Whether it's a VR simulation letting you touch a quark or a sound installation turning quantum fluctuations into a symphony, these artistic leaps remind us that science doesn't just live in labs. It's a living, breathing narrative, one that gains depth every time an artist picks up a brush, a sculptor molds clay, or a musician tunes an instrument to the frequencies of the cosmos. Chaco Canyon's sandstone walls do more than whisper ancient secrets, they sing celestial alignments carved in stone. 1,000 years ago, the ancestral Puebloans engineered their entire city to dance with the cosmos. The sun dagger petroglyph etched high on Fajoda Butte transforms into a blade of light during solstices, slicing precisely between spirals like a cosmic sundial set in motion by Earth's tilt. Meanwhile, across the Pacific, the temples of Angkor Wat stretch toward the heavens with corridors aligned to equinox sunrises, their bas-reliefs depicting Hindu deities alongside constellations as they appeared in the 12th century. These weren't accidental feats, they were acts of precision, blending astronomy with artistry in ways we're only beginning to decode. Today's artists are resurrecting these celestial blueprints, not with satellites or algorithms, but with materials their ancestors would recognize. In New Mexico, Navajo weaver Melissa Cody translates star patterns from Choco's pottery shards into vivid tapestries, her loom threads mirroring the exact angles of Orion's belt as seen from the canyon 900 years ago. Over in Cambodia, sculptor Ling II fuses traditional lacquerwork with gold leaf to reconstruct Angkorian star maps, using pigments ground from the same minerals found in temple murals. These projects do more than revive old techniques, they prove how indigenous skywatchers achieved jaw-dropping accuracy. Take the Mayan Dresden Codex. Modern astronomers were stunned to find its eclipse tables predicted lunar events within minutes, despite being penned on bark paper 8 centuries before telescopes existed. The real revelation: these ancient artist-scientists didn't just record the sky, they embedded its rhythms into daily life. The Hopi village of Orebai, arranged to mirror the Pleiades cluster, turns every harvest ceremony into a celestial reenactment. In Mali, Dogon elders still recite oral poems describing Sirius's invisible companion star, a detail Western astronomy confirmed only in the 19th century, yet preserved in their stories for generations. Contemporary collaborations like the Maori-led Matariki Lab are now digitizing these oral star lore archives into immersive 3D animations, allowing viewers to walk through southern hemisphere constellations as navigators once did. What emerges is a radical idea. Perhaps the first true astronomers weren't just observers, but storytellers and artisans who understood that to map the heavens, you first had to feel them in your bones. Nowhere is this fusion more poignant than in Australia, where Aboriginal artist and astrophysicist Carly Noon blends dot painting with astrophysics. Her installation, Silent Narratives, projects Wiradjuri star stories onto a dome, overlaying millennia-old constellation names with real-time satellite data. The effect is revelatory, showing how songlines, those ancient melodic maps of the land and sky, align eerily well with modern stellar cartography. It's a reminder that long before Greenwich became zero longitude, cultures from Polynesia to Persia were weaving astronomy into every facet of life, from the stitches in a quilt to the bricks of a temple. When a Yupik elder in Alaska teaches children to carve the aurora's patterns into walrus ivory, or a Balinese dancer's gestures trace the path of Venus, they're not just preserving tradition. They're proving that the universe's greatest mysteries were never meant to be solved by equations alone, but through the marriage of precision and wonder, where a carefully placed stone or a brushstroke at dawn becomes humanity's oldest telescope. That spine-tingling moment when you first saw the pale blue dot photograph Earth as a mere speck in Voyager's grainy frame wasn't just awe, it was neuroscience in action. Researchers studying the overview effect, the cognitive shift astronauts describe when viewing Earth from space, found that even simulations trigger similar brain activity. When test subjects in fMRI machines viewed immersive space art, their default mode networks, the brain's self-centered thought hubs quieted dramatically, while regions linked to empathy and spatial awareness lit up like supernova. This explains why standing beneath a planetarium dome swirling with fractal galaxies can feel less like entertainment and more like therapy, a mental reset button forged from stardust. Artists are now weaponizing this phenomenon for healing. The Cosmic Perspective project at London's Wellcome Collection wraps participants in soundscapes derived from solar wind data, while fractal nebula patterns pulse across curved walls, a deliberate echo of astronaut Edgar Mitchell's description of spaceflight as instant global consciousness. Early trials with anxiety patients showed heart rate variability improving by over 30% during sessions, as if the vastness of the imagery created psychological breathing room. Meanwhile, hospitals from Oslo to Osaka are testing microdoses of cosmic wonder, sealing projections of slow-motion auroras in chemotherapy wards, or VR experiences that let bedridden patients float above Martian valleys. But perhaps the most radical application comes from conflict zones. In Kiev, an underground art collective projects real-time satellite imagery of Earth onto bomb shelter walls, not as escapism, but to foster what psychologists call the big here and long now perspective. One teenager who endured months of shelling described the effect. Seeing our city as just one tiny light among countless others, it didn't make the war smaller. It made my courage bigger. Even NASA has taken note, funding studies on how Martian landscape paintings might buffer isolation in future Mars-bound crews. This isn't just about feeling small under starry skies. It's about rewiring our neural pathways to grasp interconnection. When a Navajo sand artist incorporates Hubble images into sacred mandalas, or a Japanese light installation maps every known exoplanet onto cherry blossoms, they're tapping into an ancient truth. Cosmic art doesn't just show us the universe, it remakes how we fit within it. The same awe that once guided Polynesian navigators by starlight now pulses through pixels and paint, offering modern souls an antidote to the myopia of daily life. After all, nothing puts earthly troubles in perspective like standing virtually or otherwise amid the swirling arms of Andromeda. Algorithms now paint galaxies with the swipe of a keyboard, crafting nebulae in milliseconds that might take a human artist weeks to perfect. Take Astrobiology, a neural network trained on thousands of Hubble images. It spins out synthetic starscapes so vivid they could fool even seasoned astronomers at first glance. These AI creations aren't just pretty pictures, they're tools. Researchers feed them into simulations to test how different cosmic phenomena might appear under hypothetical conditions, or use them to fill gaps where telescope data falls short. But here's the catch. While these digital nebulae shimmer with statistical accuracy, they lack something intangible: the human hand that infuses a brushstroke with wonder, the deliberate choice to exaggerate a star's glow because it feels right, not just because the data suggests it. Consider the Pillars of Creation Hubble image, where scientists and artists spent weeks debating color palettes to balance scientific precision with emotional impact. An AI might replicate the hydrogen's red hue perfectly, but would it instinctively soften the blues to evoke depth, or add a barely their gold fringe to suggest heat radiating from newborn stars? This tension sparks heated debates in observatories and art studios alike. Some argue AI is merely the next evolutionary step, a successor to the camera obscura or Photoshop, another tool to expand creativity's boundaries. Others fear it risks homogenizing cosmic art, churning out technically flawless but soulless variations on the same interstellar themes. Yet the most exciting developments live in the middle ground. At the European Space Agency's lab in the Netherlands, artists and programmers co-create neural brushes AI tools that don't replace human input but respond to it. Sketch a vague spiral shape, and the algorithm suggests scientifically plausible galaxy structures based on your strokes. Drag a color slider, and it cross-references your choice with known chemical compositions of nebula gases. The result, a collaboration where intuition guides the machine, and the machine expands the artist's reach. The question isn't really whether AI can replace human space artists. It's whether we'll use these algorithms to automate or to amplify. When a graduate student in Tokyo trains a model on both Hubble images and ukiyo-e woodblock prints, then generates hybrid starscapes that feel both cosmic and ancient, that's not replacement, it's reinvention. Or when NASA, a jet propulsion laboratory, lets schoolkids tweak AI parameters to design their own exoplanet atmospheres, watching clouds form and storms swirl in real time, that's not competition, it's inspiration. Perhaps the answer lies in how we frame the technology. An algorithm can't ache with loneliness when painting the Voyager probe drifting in the void, or feel a shiver of reverence while rendering the Event Horizon Telescope's black hole. But it can remind us, in its own way, that the universe's beauty is vast enough to need every kind of interpreter, human hearts and silicon minds alike, to grasp even a fraction of its splendor. Floating inside the International Space Station with a watercolor brush in hand, astronaut Nicole Stott isn't just painting for pleasure, she's conducting science in strokes. In microgravity, her pigments don't drip downward, they curl and spiral into ethereal shapes, revealing hidden fluid dynamics that textbooks can't capture. These aren't idle doodles, they're data. When Stott's floating blobs of Prussian blue merge with cadmium yellow, physicists on Earth analyze the patterns, gaining insights into how liquids behave without gravity's pull. It turns out that an artist's intuitive brushwork can expose phenomena even supercomputers struggle to model. Meanwhile, in the station's Japanese Kibo module, something even stranger takes shape. Molten metals poured into zero-gravity molds solidify into sculptures unlike anything made on Earth, crystalline structures branching outward in fractal splendor, their formations offering material scientists clues about atomic arrangements under extreme conditions. One such piece, titled Cosmic Casting, now resides in London Science Museum, its swirling metallic veins telling a story of molecular freedom impossible under terrestrial constraints. But why does this matter beyond gallery walls? Because every liquid crystal display in your devices, every turbine blade in jet engines, relies on understanding how materials crystallize. Traditional labs simulate microgravity with expensive centrifuges or free-fall towers. Yet here are astronauts armed with palettes and crucibles producing breakthrough science through creativity. The ESA Art and Science in Orbit program formalized this crossover, proving that a sculptor's eye for form can spot irregularities in metal foam formations that sensors miss. Perhaps most remarkably, these spaceborne artworks are rewriting cultural history. When UAE astronaut Sultan Al Nayadi inked traditional Arabic calligraphy aboard the ISS last year, the ink floated off his pen in perfect droplets, forming three-dimensional letters Madar, a first for the ancient art form. Back on Earth, conservators now study those videos to develop new preservation techniques for fragile manuscripts. From fluid dynamics to heritage conservation, the ripple effects of orbital artistry keep expanding. The next time someone dismisses painting or sculpture as frivolous, remind them, the brush hovering over that watercolor pad in 0G might just hold the key to tomorrow's bulletproof alloys or quantum dot displays. In space, where every drop of paint and molten metal dances to physics' hidden rhythms, art isn't merely expression, it's exploration at its purest. And as we venture toward lunar bases and Mars settlements, these creative experiments guarantee one thing: humanity's off-world future won't just be functional. It will be beautiful. Dark matter doesn't just puzzle scientists, it's become muse for artists daring to give form to the invisible. Walk into a gallery where sculptor Tomas Sarasno's dark matter web looms overhead, its filaments of tensioned wire humming imperceptibly. Each vibrating strand maps the hidden gravitational scaffolding of the cosmos, a tactile echo of the unseen forces bending galaxies into shape. Nearby, mist-filled chambers pulse with laser shadows, their shifting patterns mimicking how dark matter might ripple through space if only we could see it. These installations do more than visualize. They invite you to stand inside the mystery, to feel the weight of what we don't yet understand. Take the Shadow Universe exhibit in Berlin, where visitors cast silhouettes onto a wall of glowing particles. But here's the twist: their shadows don't behave as expected. Some stretch impossibly long, others fragment like broken glass, an unsettling metaphor for how dark matter warps light around unseen mass. The artist-physicist collaboration behind this piece didn't aim for scientific accuracy. Instead, they channeled the emotional core of discovery, that thrilling discomfort when reality refuses to match expectations. Even children's museums are joining this dialogue. The Dark Matter Playground in Toronto lets kids manipulate floating orbs in a zero-friction chamber, watching as unseen forces simulated by hidden magnets tug their toys off course. It's Newton's apple with a cosmic twist. You can't see what's pulling, but you witness its effects everywhere. One parent described her daughter's realization afterward. She told me the whole universe must be playing hide and seek with scientists. Perhaps most profound are the soundscapes emerging from this crossover. A Parisian collective converted dark matter distribution maps into bass frequencies so deep they vibrate ribcage more than eardrums. Standing in that sonic darkness, you don't learn about gravitational lensing, you viscerally grasp how something invisible can anchor entire galaxy clusters. This artistic reckoning with the unknown serves a vital purpose. Where equations and lectures might leave audiences feeling alienated by science's unsolved puzzles, art says, uncertainty isn't failure, it's the frontier. When a Korean ceramicist fires vessels with intentionally cracked glazes, calling them dark matter voids, or when projection artists map hypothetical WIMP particles across skyscraper facades, they're not just illustrating theories. They're reshaping how we relate to the gaps in our knowledge, turning cosmic mysteries into shared human experiences rather than academic riddles. The next time you hear physicists say dark matter makes up 27% of the universe yet defies detection, remember, artists have already found ways to let us touch it, hear it, stand in its silhouette. And in doing so, they remind us that science's greatest discoveries often begin not with answers, but with the courage to sit comfortably in the dark until the unseen slowly comes into view. The same synthetic varnish that shields Botticelli's delicate tempera from humidity now performs a surprising double duty, repairing the blurred vision of Earth-observing satellites. When prolonged exposure to cosmic rays degrades telescopic lenses, conservators adapted a technique from Renaissance panel painting, layering microscopic sheets of optically transparent resin, each calibrated to counteract specific radiation-induced distortions. The European Space Agency's restoration team found these art-derived filters improved image clarity by up to 40% compared to conventional methods, revealing glacier melt lines and deforestation patterns once obscured by digital noise. Meanwhile, the exchange flows both ways. That ultra-thin ceramic coating engineered to protect Mars rover solar panels from dust storms. It's now sprayed onto the weathered murals of Mexico City, forming an invisible barrier against smog and acid rain, while letting the vibrant blues of Diego Rivera's skies breathe through. Laboratories normally separated by disciplines are discovering shared frontiers. At Italy's Opificio del Piatador, where master restorers once painstakingly reattached flakes of gold leaf to medieval altarpieces, scientists now test how gold nanolayers could shield satellite circuitry from solar flares. The connection isn't accidental. Both artworks and spacecraft face relentless environmental assaults, whether it's a 17th century oil painting cracking under temperature swings or a communication satellite frying in Earth's radiation belt. When the Louvre partnered with Airbus engineers to analyze Van Gogh's fading yellows using hyperspectral imaging originally developed for Mars mineral surveys, they uncovered something unexpected. Traces of a rare cadmium compound that only degrades under specific UV wavelengths. That discovery didn't just inform preservation strategies, it prompted satellite designers to reconsider how certain alloys behave in prolonged sunlight. Perhaps the most poetic crossover unfolds in Kyoto, where traditional kintsugi artisans experts in mending broken pottery with gold-laced lacquer consult with JAXA engineers on self-healing spacecraft materials. The ancient philosophy that treats breakage as part of an object's history now inspires space-grade polymers embedded with microscopic gold veins. When micrometeorites puncture a fuel tank, these smart materials bleed gold to seal cracks, mimicking how kintsugi transforms flaws into radiant features. Back on Earth, the same technology preserves 12th century celadon vases in Seoul's National Museum, their hairline fractures stabilized by gold-responsive nanoceramics. This synergy reveals a profound truth. Whether defending canvas from time or satellites from cosmic rays, we're engaged in the same eternal struggle against entropy's slow march. The next time you admire a freshly restored Vermeer or crisp new Pluto flyby images, remember, they likely owe their clarity to an unspoken dialogue between museum workshops and clean rooms, where art's eternal questions meet engineering's boldest answers. A spiral galaxy swirls across your screen, its arms studded with newborn stars. But this isn't a Hubble image, it's your canvas, and with a few clicks, you're helping astronomers map the universe. Platforms like Zooniverse have turned cosmic classification into a global art project, where volunteers trace galaxy shapes, flag supernova, or even colorize ancient star maps. The magic lies in how these tasks blend intuition with science. When you sketch the curve of a galactic arm or highlight a distant quasar, you're not just categorizing data, you're interpreting it, bringing the same pattern-seeking instincts that let our ancestors connect stars into constellations. Over 50,000 amateur classifiers have contributed to discoveries this way, spotting gravitational lenses and oddball galaxies that algorithms missed precisely because they lacked human creativity's flexible spark. Then there's the astrophotographer in her backyard, whose long exposure shot of Andromeda inadvertently captures a flickering dwarf nova. With a quick upload to a community science platform like OVSO, her hobbyist image becomes a data point in a professional light curve study. Across the globe, stacks of amateur photos are stitching together celestial events too fleeting for any single observatory to catch: meteor showers, comet outbursts, even the eerie flashes of black holes shredding passing stars. What makes these contributions revolutionary isn't just their volume, but their artistry. A researcher's algorithm might pinpoint a variable star's coordinates, but it's the astrophotographer's careful tonal adjustments that reveal subtle dimming patterns hinting at unseen planets. This collaborative renaissance is rewriting the rules of who gets to do astronomy. When a retired teacher in Norway paints watercolors based on radio telescope data, or a high school student in Kenya animates asteroid orbits for a citizen science contest, they're not just assisting professionals, they're reshaping what counts as legitimate knowledge. Projects like Universe Tattoo take it further, inviting participants to design hypothetical exoplanet landscapes, then feeding the most plausible ideas into climate simulation software. Suddenly, a teenager's doodle of methane geysers becomes a test case for atmospheric modeling. The line between artist and scientist blurs beautifully here. A textile collective in Guatemala weaves tapestries from light pollution maps, their vibrant threads making invisible skyglow visceral. A musician in Reykjavik converts pulsar timings into haunting flute melodies, his compositions inadvertently revealing a rhythmic anomaly later confirmed as a binary system. Even children get in on the act. The Galaxy Zoo Kids initiative lets classrooms collage their own spiral galaxies, their playful shapes sometimes mirroring real, newly catalogued distant ones. What emerges is a radical democratization of cosmic exploration, no longer confined to PhDs with telescope access. Discovery now belongs to anyone with curiosity and a knack for seeing patterns, whether through a paintbrush, camera lens, or embroidery hoop. When a barista in Melbourne spots a galactic merger in her coffee foam photograph, or a street artist in Sao Paulo projects Milky Way time-lapses onto Fabler walls, they're proving that the universe speaks in infinite dialects. And sometimes it takes an artist's eye to hear what equations alone might miss. A meteorite shard suspended in glass glitters under Sotheby's auction lights, its $500,000 price tag reflecting a curious truth: the night sky has become the newest luxury commodity. From non-fungible tokens of digital constellations minted by blockchain artists to bespoke interior designs for billionaire space hotels, cosmic creativity is experiencing a gold rush, literally. Last year, an artist collective sold a series of lunar regolith-infused ceramics for the price of a Manhattan studio apartment, while a Dubai developer commissioned an entire art gallery shaped like a toroidal space habitat, its curved walls displaying zero-gravity sculptures priced higher than the rockets that might one day carry them. This booming market isn't just about aesthetics, it's reshaping how we fund space exploration. When aerospace startups auction off digital art to finance satellite launches, or when NASA licenses Hubble imagery to high-end wallpaper designers, the line between patronage and profiteering blurs. Take the case of Stellar Abstracts, a project that turns raw radio telescope data into generative art, with 30% of sales funding telescope maintenance. Supporters argue this model democratizes space funding, turning casual art lovers into micro-patrons of science. Critics counter that it risks reducing cosmic wonders to status symbols, their value measured in clicks and crypto rather than scientific or cultural significance. The tension crystallizes in projects like Mars Couture, where Parisian fashion houses collaborate with SpaceX engineers to create garments theoretically wearable in Martian dust storms showcased on runways at €200,000 apiece. While the proceeds fund life support research, purists bristle at the spectacle. When a spacesuit becomes a red carpet accessory, we've lost the plot, grumbled one retired astronaut during a recent panel debate. Yet even skeptics acknowledge these ventures' unintended benefits. The same diamond hard coatings developed for jewelry meant to survive Venusian atmospheres are now reinforcing planetary rover drills. Perhaps the most provocative twist comes from the legal realm, as artists stake copyright claims on novel representations of celestial bodies. From 3D printed asteroid models to AI-rendered exoplanet vistas, courts grapple with whether anyone can own a slice of the cosmic vista. A recent lawsuit over NFT-based star maps hinged on whether the artist's interpretation of publicly available telescope data constituted original work. The ruling could redefine intellectual property in the space age, potentially locking away creative interpretations behind paywalls. For every purist decrying commercialization, though, there's an innovator harnessing it. A Tokyo collective crowdsourced funds to build an actual lunar lander by selling miniature sculptures containing metal from decommissioned satellites. A Nairobi startup trains underserved youth in 3D modeling by letting them design marketable space-themed jewelry. Even the much-maligned Uranus-themed vodka brand, yes, it exists, quietly finances university asteroid mining scholarships. The debate may rage on, but one thing's clear: whether as inspiration or investment, humanity's celestial dreams are no longer confined to textbooks or telescopes. They're hanging in penthouse galleries, encoded in blockchain ledgers, and yes, sparkling on someone's wrist, a tiny piece of the cosmos repurposed as wearable wonder. Antarctica's blue ice caves aren't just scientific curiosities, they're becoming the most surreal art studios on Earth. Picture a sculptor bundled in thermal gear, carving ice formations under glow-stick light, their breath crystallizing in the air as they work. Nearby, a painter adjusts her goggles against the glare, mixing pigments that won't freeze solid before they touch the canvas. These creators aren't just braving the cold for spectacle. They're part of a growing movement where artists embed with researchers in Earth's most extreme environments, treating them as proxies for alien worlds. When a composer records the creaks of shifting glaciers or a photographer captures microbial mats in deep-sea hydrothermal vents, they're doing more than documenting. They're rehearsing for the day when human creativity erupts on Mars' rusty plains or Europa's icy crust. Take the Antarctic Biennale, where participants endure weeks of isolation and perpetual daylight to create works that echo astronauts' psychological strains. One installation featured a geodesic dome lined with prismatic film, refracting the unrelenting sun into shifting color fields, a meditation on sensory deprivation and cosmic wonder. Another artist suspended delicate wire sculptures in ice caves, their geometries warping as temperatures fluctuated, mirroring how materials might behave in low-gravity environments. These pieces aren't just art, they're stress tests for human ingenuity. How does creativity function when cut off from Earth's rhythms? Can beauty emerge from relentless austerity? The answers could shape how future colonists cope on distant worlds. Deep sea vents offer another rehearsal space. Off the Azores, a collaborative team of glassblowers and marine biologists crafts delicate models of extremophile bacteria organisms thriving in boiling, toxic waters. Working from a submersible's cramped confines, the artists mimic conditions they might face aboard a space station: limited tools, claustrophobia, and the constant hum of life support systems. Their hyper-detailed glass sculptures, now displayed in museums worldwide, do double duty as educational tools and psychological studies. The act of rendering alien-like life forms in hostile environments trains the mind to find artistry in the foreign, a skill astronauts will need when sketching Mars' barren vistas or Europa's saltwater plumes. What unites these projects is their focus on process over product. A poet journaling in a simulated Mars habitat isn't just writing verses, they're cataloging the cadence of homesickness under a pink-tinged sky. A ceramicist firing clay with volcanic minerals in Iceland isn't merely crafting pottery. They're probing how art might adapt when traditional materials are light years away. These experiments reveal a startling truth: the challenge of off-world art won't be technical. It'll be human. How do you sing when the air is thin, dance when gravity tugs differently? Weave stories when the stars overhead form unfamiliar constellations. As NASA and ESA begin selecting artists for lunar missions, the lessons from Earth's extremes become urgent. A painter who's endured Antarctic winters knows how color perception shifts in monochromatic landscapes, vital insight for rendering Mars' subtle reds. A musician attuned to hydrothermal vent rhythms might compose the first symphony echoing through Titan's methane caves. These artists aren't just future documentarians, they're the vanguard of cosmic culture, proving that creativity isn't a luxury for exploration. It's the compass that will help us navigate the profound alienness of homes not yet built. For centuries, the night sky was charted through a narrow-lens telescopes wielded by men, observatories built in their image, textbooks chronicling their discoveries alone. But the cosmos is vast enough for every voice, and today's artists are rewriting that narrative with bold strokes. Yayoi Kusama's infinity rooms don't just reflect stars, they fracture the viewer's perspective into endless iterations, challenging the myth of a singular cosmic viewpoint. Her polka-dotted planets and endless mirrors speak to multiplicity, a universe where space isn't conquered but shared. Meanwhile, Laurie Anderson's sonic sculptures turn satellite data into ethereal soundscapes, her voice weaving through transmissions like a modern-day cosmic oracle. These works do more than beautify, they destabilize, asking who gets to interpret the heavens and why. The shift isn't just happening in galleries. Indigenous artists like Dana Warren reanimate star stories that colonialism tried to erase, projecting Cree constellation legends onto planetarium domes once dominated by Greek myths. In Australia, Carly Noon blends traditional Gamma star knowledge with astrophysics, her installations revealing how Aboriginal astronomers tracked celestial events for millennia without telescopes. Even the history books are being redrawn. Digital murals now celebrate the Harvard computers women like Henrietta Leavitt and Annie Jump Cannon, who catalogued stars in the early 1900s while barred from operating telescopes themselves. Their painstaking calculations, once relegated to footnotes, now glow on city walls in vibrant hues, reclaiming their place in the cosmic canon. This renaissance of representation extends beyond Earth's atmosphere. When astronaut Jessica Meir tweeted photos of her all-female spacewalk, queer artists from Buenos Aires to Berlin reinterpreted the images as stained glass icons and neon murals, sacralizing a moment that decades of exclusion had made radical. Online collectives like Astromarginalia crowdsource zines pairing astrophysics with poetry by transgender writers, while disability advocates collaborate with planetariums to design tactile star maps for visually impaired audiences. The message is clear: the universe isn't a monolith, it's a mosaic, and every fragment, whether a Navajo elder's comet lore or a non-binary teen's speculative fiction about exomoons, adds depth to our collective understanding. The backlash, when it comes, often dresses in the language of purity. Critics argue art should stick to aesthetics, science to facts, but history tells a different story. When Maria Mitchell discovered a comet in 1847 using a telescope her father built, male academics dismissed it as luck until she proved them wrong with equations. When Katherine Johnson calculated Apollo 11 trajectory, her brilliance had to outshine racism and sexism just to reach the chalkboard. Today's inclusive cosmic art follows their legacy, insisting that who interprets the stars shapes what we see in them. A rocket's launch pad may be built on equations, but its trajectory, that's guided by imagination, and imagination thrives where diversity does. So when a queer artist paints Jupiter's storms in the colors of the pride flag, or a disabled sculptor molds meteorite clay into accessible galaxy models, they're not distorting science. They're expanding it, reminding us that the cosmos has always been richer than any one perspective could contain. A satellite image of the Amazon rainforest pulses on a gallery wall, its lush greens fading to sickly yellows year by year, not as a graph or statistic, but as a slow-motion hemorrhage of light. This is the power of cosmic-scale eco-art, where Earth's crises unfold with the stark clarity of a planetary diagnosis. Take the Cratered Earth series, where digital artists overlay timelines of glacial retreat onto lunar impact maps. Suddenly, Alaska's vanishing ice mirrors the pockmarked surface of Mercury, framing climate change not as a local tragedy, but a celestial-scale transformation. The effect is jarring when you see the Greenland ice sheet's fractures echoed in Mars Val's Marineris. It becomes impossible to dismiss melting caps as someone else's problem. Orbital perspectives amplify this urgency. The Skyglow Deforestation Project beams real-time satellite feeds into urban plazas, with algorithms tinting tree loss in searing neon red. From this vantage, the Rondônia rainforest doesn't just shrink, it bleeds across continents underfoot, turning shoppers in Tokyo or Berlin into unwitting witnesses to devastation happening half a world away. Meanwhile, the Anthropocene clock installation counts down not in seconds but in acres, its digital face fed by Landsat data. The twist, its housing is fashioned from salvaged spacecraft alloys, a sardonic nod to how space-age materials enable both environmental monitoring and the industries eroding what's being watched. What makes these works revolutionary isn't their technology, it's their emotional calculus. When the Gaia Earth exhibit suspended a 7-meter-tall NASA projection globe in museums, visitors didn't just observe hurricanes swirling. They stood dwarfed by their enormity, visceral participants in a system suddenly feeling fragile. Similarly, sound artist Joyce Ho's Frequencies of Extinction translates biodiversity loss into shifting radio static, each extinct species dimming another channel's signal until the airwaves grow hauntingly silent. This cosmic framing does more than shock, it recontextualizes. A time lapse of the Arctic's disappearing ice set against Europa's frozen crust turns climate action from political debate to evolutionary imperative. When the Pale Blue Dot Revisited project juxtaposes Carl Sagan's iconic Earth spec photo with present-day thermal imaging of wildfires and floods, the message resonates deeper than any protest sign. We're not just harming a country or continent, but destabilizing the only biosphere we've ever known. Even children's books leverage this perspective. One recent pop-up atlas lets readers zoom out from smog-choked cities to reveal Earth as a lonely oasis in the asteroid belt's void. The genius lies in making planetary stewardship feel as instinctive as rooting for a protagonist in a film. When you watch Paris's Eiffel Tower wrapped in a projected date, a visualization of atmospheric CO2, the structure choking in thicker red bands with each passing decade, you're not analyzing parts per million. You're gasping for breath alongside it. That's the alchemy these artists master, turning spreadsheets into survival instincts, ensuring that when we finally do colonize Mars, it won't be because we gave up on Earth, but because we learned viscerally, undeniably, how rare and radiant a living world truly is. A slender bamboo stick notched with tiny shells and bound with fibers might look like a child's toy until you realize it's a three-dimensional map of the Pacific Ocean's hidden pulse. These Marshall Island stick charts, painstakingly woven by navigators, don't depict landmasses but something far more subtle: the interplay of swells, currents, and stars that guides voyagers across thousands of miles without compasses. Each curve represents a wave's refraction around distant atolls. Each shell cluster marks where celestial paths intersect with particular tides. What Western explorers once dismissed as primitive art is now recognized by oceanographers as a hydrodynamic masterpiece, a tactile algorithm encoding centuries of observational math. Half a world away, Navajo sand painters conjure the cosmos in ephemeral grains, their intricate patterns mirroring the dance of Pleiades and Orion. To the untrained eye, their stunning geometric designs. But watch as elders place yellow pollen at precise points representing solstice sun positions, or trace the Milky Way with crushed gypsum, every gesture a node in an ancestral astronomical model. Modern researchers collaborating with Navajo scholars have uncovered something astonishing. Certain sand paintings' spiral structures correspond to lunar nodal cycles, tracking eclipses with precision rivaling early telescopes. Today's artists and scientists are breathing new life into these ancient systems through unexpected tools. In Honolulu, a collective scans century-old stick charts with LiDAR, revealing subtle curvature variations that correspond to wave harmonics previously undetected by satellite altimetry. Their digital reconstructions prove what oral traditions always asserted, that Pacific navigators intuitively grasped Fourier transforms long before European mathematicians named them. Meanwhile, at Arizona State University, astrophysicists partner with Diné Navajo multimedia artists to animate sand painting sequences as planetarium shows. As the projections shift, stars blooming from central dots, constellations stretching into seasonal alignments, viewers witness celestial mechanics through indigenous computational lenses. These collaborations aren't just preserving heritage, they're shattering assumptions. When a physics journal published a paper analyzing Polynesian star compass diagrams as topological graphs, it forced academia to confront its blind spots. The diagram's angular relationships between star risings encoded spherical trigonometry solutions that predate European navigational tables by generations. Similarly, when Australian Aboriginal songlines oral maps linking landforms to stars were recently modeled as acoustic wayfinding algorithms, they demonstrated error correction properties akin to modern GPS. The implications ripple beyond history books. NASA now consults with Micronesian navigators about wave pattern recognition for autonomous spacecraft, while MIT's Media Lab adapts Navajo spatial models for asteroid mapping. What emerges is a profound recalibration of who gets credited with scientific insight. That intricate basketry from the Philippines, its fractal weave matches orbital resonance patterns in Saturn's rings. Those intricate Incan-Quipus knotted chords, once dismissed as mere accounting tools, their three-dimensional binary coding now informs quantum computing architectures. Even the humble Cherokee double-woven basket with its hyperbolic geometry finds echoes in theories of curved spacetime. The lesson is clear: when we dismiss cultural artistry as decorative rather than analytical, we're not just erasing contributions, we're robbing ourselves of millennia's worth of cosmic intuition. By digitizing these living archives, today's interdisciplinary teams aren't merely translating indigenous knowledge into Western frameworks. They're proving that the universe reveals its secrets to those who listen in every tongue, whether through equations, star songs, or the whisper of reeds lashing against a canoe in open ocean. Standing in front of a sprawling mural of the Milky Way, your brain isn't just processing colors and shapes, it's undergoing a neurological symphony. Recent fMRI scans reveal something extraordinary. When we gaze at cosmic art, regions like the default mode network light up with activity, the same neural circuits tied to daydreaming, empathy, and those rare aha moments of insight. It's as if the vastness of the universe triggers a parallel vastness within our minds, unlocking a state where creativity and contemplation collide. Museums have taken note, designing awe walks through galaxy-filled galleries where visitors report feeling not just educated, but emotionally expanded, as if the artwork recalibrated their sense of scale in the world. Take the Cosmic Reverie experiment at London Science Museum, where participants wore EEG headsets while viewing nebulae projections. The result: brainwave patterns shifted toward frequencies associated with relaxed focus, similar to the effects of meditation. Even more striking, follow-up surveys showed participants scored higher on problem-solving tasks afterward, suggesting that cosmic art doesn't just soothe, it primes the brain for breakthrough thinking. Neuroscientists speculate this might stem from an evolutionary quirk. Our ancestors relied on celestial patterns for navigation and storytelling, wiring our brains to associate starry vistas with exploration and meaning. Artists are now harnessing this neural alchemy intentionally. At the Griffith Observatory in Los Angeles, a collaborative installation pairs Hubble imagery with generative soundscapes tuned to 60 Hz, a frequency shown to enhance gamma brainwaves linked to learning. Visitors describe the experience as thinking in constellations, their usual mental chatter replaced by a serene, interconnected flow. Meanwhile, hospitals from Tokyo to Toronto are piloting stellar therapy rooms where patients undergoing stressful treatments relax under dynamic projections of auroras and supernova, with early studies showing reduced pain perception and anxiety levels. The implications ripple beyond gallery walls. Imagine classrooms where diagrams of black holes double as neural catalysts, or office spaces where cosmic murals replace sterile whiteboards to spark innovation. Even urban planners are experimenting. A Stockholm subway station adorned with a mosaic of the local night sky saw commuters report higher mindfulness and reduced claustrophobia. It turns out that art framing Earth as a tiny dot in the cosmos doesn't provoke nihilism. It fosters a quiet, grounding perspective like mental deep breathing. This isn't just about beauty, it's about neurobiology. When a child traces the spiral of a galaxy with their finger, or an astronaut's photo of Earthrise floods a social media feed, they're not just sharing images. They're inviting brains to flicker into a rare state, one where the boundaries between self and universe soften, and for a fleeting moment we feel both insignificantly small and profoundly connected. And in that neural sweet spot, curiosity doesn't just grow, it takes flight. The future of space art isn't confined to canvases or screens. It's erupting into dimensions we've barely begun to explore. Picture walking into a lunar habitat where the walls aren't just painted with galaxies, but alive with holographic murals that shift as you move, their nebulae swirling in real time, synced to orbital data from passing satellites. Or envision sculptures not carved from stone, but grown delicate lattices of bio-engineered fungi fed by iron-rich asteroid dust, their filaments glowing faintly with embedded bioluminescence as they metabolize cosmic radiation into art. These aren't science fiction daydreams. They're prototypes already taking shape in labs from Tokyo to Cape Canaveral. One of the most audacious experiments is unfolding at the European Space Agency's ME-LI-SSA program, where researchers collaborate with bio-artists to cultivate living murals aboard the International Space Station. Using extremophile algae genetically modified to respond to cosmic rays, their creations pulse with color shifts as radiation levels fluctuate, transforming the invisible hazards of space into a dynamic visual symphony. Meanwhile, MIT's Mediated Matter Group is 3D printing lunar soil into intricate sculptures, their porous structures designed to refract sunlight into prismatic displays that mark the passage of time without clocks. But the frontier isn't just about materials, it's about communication. The METI project's interstellar messages, destined for potential civilizations light years away, don't rely on dry mathematical codes. Instead, they're woven with harmonic intervals from global musical traditions and visual symmetries found in both human art and quantum crystal structures. The logic is radical yet simple. If beauty is universal, then artistry might be the most precise language we have. When the team recently encoded a Bach fugue alongside Fibonacci-based animations into a laser transmission aimed at Proxima Centauri, they weren't just sending data. They were launching the first interstellar art gallery. Back on Earth, these experiments are rewriting what galleries look like. The zero-gravity art collective's orbital exhibition, Celestial Bodies, didn't hang paintings. It released floating sculptures of electro-spun nanofibers inside a parabolic flight, each piece evolving in midair as microgravity twisted its threads into unforeseen forms. Visitors watched through VR headsets as the sculptures morphed, their shapes echoing the dynamic chaos of galaxy formation. What unites these projects is a bold reimagining of art's role in our cosmic future. It's not just about decoration or expression, but about creating new sensory languages for environments where traditional aesthetics fail. When a team at the University of Stuttgart designed a Mars habitat with walls that breathe via shape memory alloys, their primary consultant wasn't an engineer. It was a choreographer who understood how movement could combat the psychological rigidity of confined spaces. Similarly, the first lunar graffiti won't be spray-painted. It might involve genetically modified lichens that grow in phosphorescent patterns when exposed to astronaut breath. The question isn't whether art will accompany us to the stars, but how it will evolve once freed from Earth's constraints. Will Titan's methane rivers inspire sculptures that flow upward? Will quantum entanglement spawn duet performances between dancers light years apart? As we inch closer to answering these questions, one thing becomes clear: the next Renaissance won't happen in Florence. It'll ignite inside a cramped airlock, a biolab on Mars, or the flicker of a laser beam racing toward distant suns where artists and scientists, armed with tools their ancestors couldn't fathom, redefine what it means to create.